Hi class, today we're going to be talking about the area of three different shapes that should hopefully seem familiar: trapezoids, rhombi, and kites. There's going to be two formulas that we're going to use, and we're pretty much just going to jump right into some examples. We're going to start off with the trapezoid. If you remember when we first learned about these shapes, a trapezoid is a shape that has four sides and two parallel bases, and then in a specific case the isosceles trapezoid would have two congruent legs on either side. So just as a reminder, this is a base here at the top and this is a base here at the bottom, so we'll call this base 1 and base 2. And then the only other thing you're really going to need for your trapezoid in order to find the area would be the height. And the height is always going to be the perpendicular distance from one base to the other. So anytime you're talking about altitude, you're going to be referring to something that makes a right angle. And then our formula here is that the area is 1/2 the height times base 1 plus base 2. So you're going to add the bases, multiply it by the height, and then divide it by 2. It almost looks like the area of a triangle, except you've got two bases instead of one, so maybe that's an easy way to remember it. The other two shapes have the same formula, and those are your kite and your rhombus. So the kite and the rhombus use strictly the diagonals, and diagonals will go from one corner to another, like this or like this. So we've got diagonal 1 and diagonal 2 here. And you just have to remember the key characteristics about a rhombus and a kite. Remember, in a rhombus, the diagonals are bisected. And that's going to be important if you're missing some lengths. So that means if this was 10, so is this one. And if this was 12, so is this side as well. And that's going to make it a little easier to find your total diagonal lengths. For a kite, however, only one set is bisected, and that's typically going to be the shorter one. For example, this could be 5 and 5, and then maybe this long diagonal here, maybe this is 7 and this is 18. All right, so when you're using this formula here for a rhombus or a kite, make sure that you find the total diagonal of each, not just one individual part. And what you're going to see on the rhombus and on the kite is that occasionally you're going to have to use some right triangle trig. That's the SOHCAHTOA that we've learned about and used so much, especially if you are missing a part of a diagonal length. You also might use Pythagorean theorem if you've got some right triangles, and we might see an example of that today. Let's start with our first example, which is with a trapezoid. So it says find the area of the windshield. So notice we've got this trapezoid type shape here. I know it got cut off a little bit, but our base 1 is 72 inches. The base 2 is 85, and then our height in this case is 38 inches. Because we've got everything we need to know, we just have to plug it into our formula. So we'd have 1/2 times the height, and then we add the two bases. So 72 plus 85. And then you could just go from there, simplifying. So I'm going to do 72 plus 85 first. That's going to get us 1/2 times 38 times 157. Then I'm going to go ahead and multiply 157 times 38. So that's going to get us 1/2 times 5966. And then divide that by 2, and we get that the area is equal to 2,983, and this is going to be in inches squared. And because we're finding area, please make sure you include your units. All units are to the square power. All right. Example 2 is a little bit backwards because it says here they tell you the area, and then they give you the bases, and they want to know what's the height. All right, so this is going to be working backwards. So if you've got your formula here, what you just need to do is plug in the numbers that you know and then solve. And so we've got the A is 332. We know 1/2 stays. We don't know what H is, but we know the bases are 12 and 14. So if we start to solve this, I can go ahead and add 12 and 14, leave everything else the same, and that's going to get us 26. If I divide 26 by 2, we're going to get 13H. And then the last thing that we could do is divide both sides by 13. So 332 divided by 13, that's going to get us that the height is roughly 25.5 feet. And then we're done. So all you got to do is plug in what you know and then solve. The last two examples that we're going to see are with the rhombus and the kite. So notice in this example here, we've got a rhombus. All sides are congruent, diagonals are bisected. So because we know these are 7, we can tell here that this is 8, which means that this is also going to be 8. So our diagonal 1 would be the 7s together, so that'd be 14. And diagonal 2 would be 16. So if I plug into the formula, I got 1/2 14 times 16. So those are tend to be a little bit easier. And if you multiply all of that out, you get, let's see, 14 times 16 is 224 divided by 2. So you get the area of this rhombus was 112 and then meters squared. Now, example 4 is a little bit more work. Here, they don't tell you much about any of the diagonals of the kite except for this here, but we can figure out parts of our diagonals by using the fact that we've got a right triangle. So we've got to use Pythagorean theorem here. So 10 would be the hypotenuse. So we're going to say 10 squared equals the one leg we know, so that's 6 squared, plus the other leg we don't. And now we could go ahead and solve. So we've got 100 equals 36 plus x squared. If we subtract 36 to the other side, we get 64. So x squared equals 64. And then square root both sides, we get that diagonal length is 8. And remember, we said earlier, kites have diagonals that are split. So if that's 8, this one is also going to be 8. And the only other thing you have to figure out is this diagonal, the longer part. And again, that's using Pythagorean theorem, but this time with this triangle. So we've got 8 as one of our bases, or our legs. We've got another side we don't know, and then 17 would be our hypotenuse. So we're just using right triangles. 17 squared gets you 289, and 8 squared is 64. If I subtract 64 over to the other side, we get that y squared is 225. So taking the square root of that, we get that the diagonal part there is 15. So I'm just filling in what I know. And now this helps us identify our final diagonals. So diagonal 1 is 8 and 8, so that's going to get us 16. And diagonal 2 now we know is 15 plus 6, which is 21. So we can go to our final formula, 1/2 diagonal 1 times diagonal 2, 16 times 21, divide that by 2, we get that the area is 168 inches squared. And we're finished. All right, so if you have any questions about the formulas or how to plug in, make sure you let me know. I didn't do any examples with SOHCAHTOA, but you guys should know how to use that hopefully by now. But if you do come across one and you have questions, just ask and I'll walk you through that. The only other type of example you might see is if I give you a set of points to plot and ask you to find the area. And there's kind of a 4-step process. The first is to plot the points, then determine what kind of shape it is, and to do that you might have to find necessary lengths. So you might have to find the lengths of the bases, maybe you have to use distance formula and find the lengths of the diagonals, and once you know what kind of shape it is, once you know the lengths of those segments, then you just plug into your area formula. So if you need an example of that, let me know, but hopefully that would be pretty easy. You just might have to end up using the distance formula for those types of problems, depending on the information that is given to you. All right, that's it for today. Thanks for listening.